Hello, Calc BC. I'm going to do a couple of quotient rule problems from your homework just to make sure that you feel okay about your quotient rule. And our quotient rule, we are looking at it as a function divided by a function. And if we wanted to then find our, let's say that we called this new function h of x, right? Let's say we called it h of x, and it was now f of x divided by g of x. If I wanted to find h prime, I would take and do low d high. So I take the low function times the derivative of the high function minus high d low. So the high function times the derivative of the low function over the square of what's below. Okay, so I'm going to tell you that again. Quotient rule. Low d high, and that's multiplication, minus high d low over the square of what's below. Low d high minus high d low over the square of what's below, meaning the square of the low function without the derivative. Notice that you're not taking the derivative at the bottom. Low d high minus high d low over the square of what's below. So let's try it for number 4. My s prime of theta. Low d high, so the derivative of cotangent is negative cosecant squared theta, minus high d low. There's my high function times the derivative of my low function. Now you're just taking the derivative of it. Notice it's just g prime here in the definition. So, oh golly. So you are, let me put that back, I'm sorry. You are just taking and finding d theta of theta to the 1/2. So that's going to be 1/2 theta to the negative 1/2, or 1/2 times the square root of theta is your derivative. So low d high minus high d low over the square of what's below. So I'm going to take this and square it. And I'm going to erase that so we have some space. Sorry. Because we need to simplify. So negative square root of theta cosecant squared theta minus, now this is where things get a little bit complicated because you have a complex fraction. And this is just theta, okay? So what you could do is say, well, I'm going to go ahead and get that theta up here, get it out of that complex fraction. And when I do that, this is a binomial, so it's going to have to be distributed times that times that. So when I do that, I get negative, and I'm going to make this theta to the 1/2 over theta to the 2/2, because when I distribute, basically those two are going to get, that's what it's going to look like. Minus, and this is going to be 1/2 theta to the 1/2 times theta to the 2/2 cotangent theta And then this denominator goes away. So now we have to simplify, this. So if I bring my 1/2 down, it's going to become -1/2 in the denominator. So this would be -1 over theta to the 1/2 cosecant squared theta. This one's going to be -1 over 2 theta to the 3/2 cotangent theta. So now, common denominator, right? Common denominator is going to be 2 theta to the 3/2. So I would have to multiply this one by 2 theta over 2 theta. And then I would have the exact same denominator. So this is going to be -2 theta cosecant squared theta minus cotangent theta all over 2 theta to the 3/2. And I know that that looks ugly, but some of these quotient rules, you've got to get it into the place where it's going to ask you where your derivative is, 0 and where it's undefined. And so you have to have it as one fraction. And that's how you would do it. We just got it to the point where I had 2 theta to the 3/2 on both denominators, and so I added my numerators over one denominator, and we got the answer. So let's do another one. Let's do number 5. And this one's pretty easy. I should have done this one first. Low d high minus high d low over the square of what's below. Do not worry about simplifying it, doing anything with the denominator. Okay, we don't want to worry about that. 6x to the 4th minus 6x minus, and this would be 9x to the 4th. Keep this just x to the 3rd minus 1 squared. Okay, don't mess around with it. You do have like terms here, so we'll combine those. -6x minus 3x to the 4th over x to the 3rd minus 1 squared. And that would be your derivative. So this one was much easier. Okay, so that is a couple of examples. Of course, number 4 was kind of a doozy because it had a square root and it had trig, and you had to find a common denominator and add them. But it wasn't horrible. I mean, you could have stopped at a certain point, but you're going to have to learn how to do this anyway, so you might as well kind of start. But hopefully that helped on an example of the quotient rule.